Hello, everyone. So let me introduce Dr. Catherine Nelson. She'll be talking about going from notebooks to scalable system. Let's give it up for Dr. Catherine.
Well, hi, and thank you for the introduction, and thank you all for coming to my talk. I really appreciate it. I'm super happy to be here. I was really excited to get a talk accepted to PyCon in 2020, but didn't get to present that one in person. But finally, I am able to present my first real-life PyCon talk, going from notebooks to scalable systems. And I've put everything for this talk on GitHub. There's the slides, the code, the links to the data, the further reading, and how to connect with me on LinkedIn and Blue Sky. So you can follow along in that GitHub repo if you would like. I'm going to quickly introduce myself. I've been in data science for about 10 years, always with my main focus on machine learning. I've written 2 O'Reilly books. The first came out in 2020, and that was about production machine learning systems with TensorFlow Extended. And the second one, which came out last year, was Software Engineering for Data Scientists, which is a guide to help data scientists use software engineering best practices. And this talk is a deep dive into one chapter from that book. Most recently, I've been doing some contract work for AI startups, and I was finishing my book. And before that, I was a principal data scientist at SAP Concur, working on production NLP models. Before that, before I switched careers into data science, I was a geologist. That's me doing geological fieldwork in Arctic Greenland. And when I'm not doing all these things, I'm outdoors, hiking, climbing, and skiing. And the middle picture is me on the summit of Mount Rainier in Washington State. So why did I decide to give this talk? This talk is all about how you can take code from a notebook to being part of a bigger system, a system that can really scale up. It's a common situation that many Python coders encounter, and in particular data scientists and other data professionals. You start by writing some code that's just exploring a problem, visualizing the data, but eventually you want to make your code part of a bigger system. And there's no standard techniques for going from one to the other. So I'm both putting forward my opinion on some best practices and asking the community to think about this. I'd love to chat during the rest of the conference and hear your opinions. What works well for you? What's not so easy? And before I get into the details, I want to make this clear that this is not an anti-notebook talk. I love Jupyter Notebooks. They're awesome. They're one of my favorite tools to use when I'm writing code. Here's a few reasons why I love them. Jupyter Notebooks are particularly great when you're exploring, you're not too sure where you want to go or how you want to do it. You want to try a bunch of different things and just see what is successful. You want to try things out and get direct feedback. You want to view the results of running your code. You want to display some data and interact with it. You want to see what the columns are in your CSV. You want to see if there's missing data. You might want to view some summary statistics of your data, and then that's going to affect the code that you write next. You want to code along with the text for yourself, like in a scientist's lab notebook. You want to teach something. Notebooks are amazing for tutorials, so you can explain all the code that you're writing. And you want to quickly generate visualizations of your data and look at those along with the code. And you might want to change some things up and then see how those visualizations have changed. But there's a few things that are less great about notebooks. It's really easy to run cells out of order and end up with code that just doesn't match because the state of the variables has changed. And it's easy to leave in code that you're not using. It's not super easy to use notebooks with version control. On the right of this slide, you can see an example of how GitHub deals with the differences between 2 notebooks. The code hasn't changed, but the metadata has. So Git sees this as a difference with hundreds of lines changed. And It's tough to scale notebooks. It's hard to automate code that's in a notebook to make it part of a bigger system. And it's hard to reuse parts of code from a notebook in other places. The way we use notebooks often doesn't encourage us to write modular code, and it's hard to import functions from a notebook into a standalone script. But then this isn't what notebooks are designed to be good at. But a standard Python script is a much better fit for all of these things. So when should you move from a notebook to a standalone script? This isn't always easy to figure out the exact timing of this, but a common pattern is when you want to put your code into production. It's also a good idea to move to a standalone script when you want people to be able to reuse your code easily. You should move to a script when you want your code to run without you touching it, when you need to guarantee that your code is robust, and when your notebook has got super complex and you can't remember what order you should run the cells in. And the really key point that I want to make here is that moving from notebooks to code that scales is all about a mindset change. When you're writing code in a notebook, it's all about exploration and flexibility, which is great for unstructured, free-flowing, experimental code. But when you move to scripts, you want to make your code easier to maintain, more robust, and more reproducible. You should do that at a point where you know what problem you're solving, and you want to run that code repeatedly. And yeah, if you take one thing away from this talk, it's that mindset change on moving out of a notebook. So I'm going to show you how to go from a notebook to code that scales with a little example project. And I've chosen a simple machine learning model to demonstrate this. I'll show you what the notebook looks like to start with, and then I'll show you my opinion on the best techniques to refactor it, and show you what I ended up with. So let's classify penguins. Let's build a machine learning model to classify penguin species. I'm using a data set called Palmer penguins that has data on body features of 3 different species of penguins from Antarctica. So given data on their flipper size, the bill length, the bill depth, and the body mass, build a model that predicts what species the penguin is. And the features are going to be the flipper size and the bill length, body mass. Labels are going to be the species. And then we'll take that code from a notebook to standalone scripts as if we were going to deploy that model to production. So I made a notebook that builds this penguin classification model, going from downloading the data through training a simple machine learning model to making predictions on new data. And don't worry about looking at all the details of the code. I'll explain everything that's going on in the notebook. In this section of the notebook, I've downloaded the data for the project, and the data set contains a bunch of features, some of which we're going to use for the model. It contains the species, the island they're found on, the sex of the penguin, and the body features. And this is typical notebook code that I'm writing here. I'm viewing the data, I'm looking at the number of null values in the column, and at this point there's nothing that's in a function. I'm just running individual statements. In the next section of the notebook, I've dropped the missing values, selected the columns with relevant features, displayed the data again to check that it all looks okay, displayed the number of instances of each particular penguin species, and converted it to NumPy arrays. Next, I want to prepare the data for the machine learning model. I'm going to take a look at the features to check that my data cleaning step has worked. And then I will scale the numeric features so that they have 0 mean using pre-processing functions from scikit-learn. Then I've encoded the labels as numbers instead of strings. And I've split the data into train and test data with 80% for training and 20% for testing. Finally, I train a logistic regression model using scikit-learn check its accuracy on my test data set, and make a prediction on some new data. Along the way, I've printed out the classification report so I can deep dive into the details of how my model is performing. And many notebooks look a lot like this. There's a lot of different tasks being carried out in the same file. The code is in statements that run immediately rather than being in functions, and there's all this extra code dotted around that isn't necessary for the actual functioning of what I'm doing here. And this code doesn't scale. You can't run it automatically, you don't have guarantees that it'll do what you expect, and you can't reuse parts of it elsewhere. So let's take a look at a couple of tools you can use to pull all the code out of a Jupyter Notebook and put it into a Python script. And I'll look at mbconvert and Jupytext. mbconvert is a really useful tool for pulling all the code out of a big Jupyter Notebook so that you don't need to just copy and paste. You can install it with pip, and then just run a single command on the command line to convert your notebook into a script. And this is the output it gives you. So all the code in the notebook is in the script, and you could just run that script, and all the markdown and the metadata from the notebook are commented out. You could just wrap this all in one big main function and run it, and everything that's in this notebook would run. And if you have a very simple notebook, this might be all you need to do to convert your notebook to a script. Jupytext is another similar library that offers similar functionality. Again, you can install it with pip. You can run it with a single command. And the output is pretty similar to that of mbconvert. You get all the lines of your code in a .py file, and the markdown is commented out. So you could do the same thing as with mbconvert for a simple notebook and just wrap it all in a big main function. Jupytext has an extra function compared to mbconvert, where you can pair your notebook and your script. And this lets you sync them. So when you update your notebook, the script updates. And again, simple notebook, you might be done at this point. But most of the time, just copying everything from your notebook to a script is not enough. You're going to need to change your notebook code up to really make it scale. So let me take you on a brief notebook refactoring journey to take your notebook code to production-worthy code. So taking your overall notebook that starts out with all these tasks in one big file, here's your overall checklist of what you'll need to do. You need to separate code out into different tasks, organize that code into functions, write the tests so that you know that your code does what you expect it to do, either unit tests or integration tests. And finally, make it shareable by sharing the modules it depends on, its requirements, and you can use CI/CD tools to deploy it. So let's go into this in a bit more detail. First, you need to identify all the steps within your notebook. And drawing a diagram can be super helpful here, or a flowchart. What are all the steps that you're trying to do in your big notebook? And a step in this case could be download the dataset or try out different machine learning models. And then decide which of these steps you need to keep. If you're trying out a bunch of machine learning models in the notebook, you only want to train one in the final code. Next, write a function stub for each step that you've decided to keep, where you just name the function. For each function, what are going to be the inputs and outputs? For example, a model training function would take features and labels as input, and either save the model or return it as an output. Then add in the code, making sure that it takes the inputs you want it to and outputs what you want it to do. And then write a test to check that it actually is what's happening. So let's go through this process with the Penguin classification code. Here's all the steps in constructing a model to classify penguin species. Load the penguin data, clean out the missing values, scale and encode the features and the labels, train the model, and then make predictions on new penguins. And let's set up some function stubs for each of these steps. And setting up like this with the pass keyword means that you can test the code with no errors. You can run it when your code is incomplete. And this gives you an overview of everything that's going to happen. Next, add the function inputs and details of what's going to happen in the function and what it should return. So I like to add in comments with all the things that are going to be in your function at this stage. But you could also write full doc strings. So the first function here, the download data function, takes the file path to save the data as an input. It checks to see if the file has already been downloaded, and if it doesn't already exist, saves it to that location. Then there's a function to clean the data, which will load the CSV file from the previous step, drop any rows with missing values, and transform the data to NumPy arrays for the features and for the labels. The preprocess function has two arguments, the features and the labels. And these are going to be NumPy arrays. The categorical variables will be encoded. The numeric features will be scaled to have zero mean. And then the function will split the data into training and test features and labels and return NumPy arrays for the training features, the training labels, and the test features and the test labels. Then the train model function will take in the training features and training labels, train the model that I decided on in the notebook, and save the trained model. And finally, there's a function to make predictions on new data, and this will load the model, make predictions, and return a string that's the predicted penguin species. Then you can drop the code from the notebook that actually carries out the functionality into this function stub. You can either do that directly from the notebook or using NB-convert or Jupytext, as I mentioned earlier. And this is the easy part once you've actually factored that code, once you've worked out what all the steps should be. So here's the code for the data cleaning step, which loads the data from the CSV file, removes any rows with missing values, and converts the features and the labels to NumPy arrays. Then it's a really good idea to write a unit test to check that this function is doing what you expect it to do, in particular so that you don't make copy and paste errors. To test the data cleaning step, I'm going to create a simplified CSV file that I can load quickly and test that the data cleaning code is doing what I expect it to. And this also includes some none values, some rows with some missing data, so that I can check that those rows get removed correctly. Then I create a unit test that checks that the clean data function is doing what I expect it to. This uses the create the test data function from the previous slide. It runs the clean data function. It checks that the features and labels arrays are the correct shape and that the row with the missing data has been removed. It checks that all the classes are correctly present in the labels array, and it cleans up after itself by removing the CSV file it created. And this structure of a test, this arrange, act, assert, clean up, is a really useful structure for setting up a simple unit test. So let's do this again with another step in the notebook, the pre-processing step. This code takes in NumPy arrays of the features and the labels, scales the features, encodes the labels, and returns training and test features and labels that are ready to use to train the model. And here's the test for the pre-processing code that I've included in the previous slide. Again, I've set it up to work with some simplified data. In this case, I'm just creating that data within the test. And I've tested that all 4 of the returned arrays are the correct shape, and that the labels are in the set of 0, 1, and 2 so that I know that they've been encoded correctly. And then you can repeat this process with all the other steps in your notebook. Then you'll end up with code that is modular, you can automate it, and you can use it in other situations, and other people can easily use it too. I won't go through all the other functions in this talk, but if you want to check them out, head over to the repo that I put together. I've put the original notebook in there, along with the refactored code for each step, and there's tests for all the functions. And there's one last thing to add as part of our refactoring process, and that's an overall function that can run all the functions that we've created in all the different steps. So this run training pipeline function calls the download data, clean data, pre-process data, and train model functions. The overall input is the file paths to save all the artifacts it creates. And the outputs are a saved data set and a saved model. But all of these functions could be reused elsewhere in the system if you want, and you can set up this overall function to run automatically and retrain your machine learning model whenever you want. So breaking down your notebook code into modular, organized code is the main way of getting to scalable code. Other things that really help are making sure that your code is consistently formatted, making sure your code is well documented, using CI/CD tools to automate your tests. And you can also separate out the configuration and settings into a separate file. And all of this will make your code easier to maintain, more robust, and more reproducible. You'll need some key skills here. One of the most important skills is being able to break your code down into sensible modular functions. When you have a big sprawling notebook, working out all of the steps that you're doing, that's the key first step. Making sure that each step is as efficient as it needs to be, also really useful. And using tests so that you can refactor your code while still keeping the same functionality. And then using automation tools to speed up your whole workflow. But most importantly, you should pick the right mindset and tools for what your code is going to do. Use a notebook for exploring, for trying things out, for looking at what's going on when you're writing your code. But then, when you want to put it into production, move the functionality of your code into modular functions and write tests so that you know that those functions work. Think about making your code robust, reproducible, and able to run automatically. If you would like a copy of Software Engineering for Data Scientists, O'Reilly have kindly provided 10 copies for me to sign and give away. And my friends at Anvil are hosting me for the book signing. Come and find me at 2 p.m. at their booth in the expo hall today. And I encourage you to go and check out their tech anyway, they're awesome. And I just wanted to say thank you for the PSF for providing a travel grant that let me be here today. And thank you all for coming, I really appreciate it.
Hi, thanks for the talk. I just had a quick question. Do you have thoughts on using frameworks to kind of aid with this, like structuring into like functions and tests and things like that, like Kedro?
Yeah, I have looked at Kedro a little bit in the past, and I did find it useful. But I think that it's something that you might want to come up with at a team level rather than looking at an overall tool for this, because you'll have some, if you're working in a data science team, you're going to have some like commonalities between the notebooks that you're writing that aren't really shared much with other places externally. So writing your own tools for your team, I think, is really the key step here.
Thanks for the nice talk.
Yeah.
Do you have any special method to come back to the notebook? So if you export everything into a Python file, but very often you're not done. You just want to come back when experiment with. Do you have any kind of strategy how to kind of get a round trip? So from your functions back to the notebook and notebook to the functions?
I think I would try and set things up so that anything that I want to reuse, I turn into a function. And then I import that function from the .py file into the notebook. would be how I'd go about that.
That's exactly how I do it, but maybe you had some more tricks up your sleeves. No.
Oh.
Hi, thank you for the talk. Does NB convert or Jupytext, when you convert the Jupyter Notebook into a Python script, does it output like a requirements file or a pyproject.toml file? So,
I don't know. I didn't find that when I was writing this talk, but yeah, you'll need to check the documentation for that one, because that would be really useful.
yeah, all right, thank you.
Hey, thanks for the talk. As a software engineer, that made me really happy. I guess my question is more kind of a social one. Like how do you get data scientists or other people for whom software engineering isn't their primary competency, but who are, very comfortable using a Jupyter Notebook? Like, I think this was a talk, kind of laid out how to do it, but like, how do you convince somebody like that that this is important, more important than the other 10 things that they have to do?
Yes, this is why I wrote my book, because I want to get more data scientists writing good code. But it is overwhelming as a data scientist, because you're like, oh, I need to learn all the 100 different things that are in data science. But I think it comes down to a communication issue. So software engineers should be more willing to explain to data scientists why they should be spending more time improving their code rather than exploring new things. And data scientists need to be open to listening. And what I tried to do in my book was to just make all the terminology really accessible. I mean, when I first started as a data scientist, I was like, what is an API? I have no idea. And I'd go and look it up, and I'd find I'd get super deep into web development pages. So yeah, all about communication.
Thank you.
Yep.
Do you have a strategy for dealing with the inevitable global variable that is what makes most of the notebook cells all work correctly, and then when you decompose it to a function, I can't figure out why it doesn't work?
Probably a configuration file in that situation. Like, if you have all these floating within your notebook, then being diligent about separating those out and putting them into the separate file would be how I tackle that.
Thank you very much. That was really insightful session. Let's give it up for Dr. Nelson.